Welcome to homework.
All right, so problem number 45 asks to consider a beam of free particles that move with a velocity v is equal to p over m in the x direction and are incident on a potential energy step u equals 0 for x less than 0 and u equals x for u and u equals x is equal to u0, which is less than the energy for x is greater than 0. So basically, let's draw our barrier here. Give myself some more room. I'll do it over here. All right, so it's basically a step barrier like that, where we have u0. This is 0. This is our x-axis. And this is our u of x, our y-axis, basically. U of x. U of x, and that the energy of the free particles is greater than u0, so it's somewhere up here. So this is E. So when it encounters the barrier, okay, so let's start with writing down what else we know here. So the rest of the equation. So the wave function for x equals less than 0. So this is x equals 0. This is less than 0. This is greater than 0. We're given psi of x is equal to a e to the I k1 x plus b e to the minus I k1 x for x is less than 0. And then we're given that the wave function for x greater than 0, psi of x is equal to c e to the I k2 x for x greater than 0. So we want to use the conditions that both psi and its first derivative must be continuous at x equals 0 to find all of our constants in terms of a, k1, and k2. So that basically means that at this barrier, this wave function cannot be discontinuous, and neither can its derivative. It has to be a continuous transition across the barrier. So we will, so the first boundary condition for that allows us to write that these two wave functions are equal at x equals 0. So we have a e to the I k1 times 0. Sorry, that's supposed to be a 0, not an x. k1 of 0 plus b e to the minus I k1 times 0 is equal to c e to the I k2 times 0. All right, so e to the zeros, these are all became 1, so you end up with a plus b is equal to c. So now we want to use the same conditions for the derivatives. So let me psi 1, psi 2. So d psi 1 of x dx is equal to, so it's just k1, so I k1 a e to the I k1 x minus I k1 e to the minus I k1 x d psi 2 of x dx is equal to I k2 c e to the I k2x. That's supposed to be K2. Okay, so now we use the same condition that the derivatives have to be equal at x equals 0. So we'll set that here. So we'll call this 1. It's not a very good 1. And then we'll call 2, equation 2, I k1 a e to the I k1 times 0 minus I k1 e to the, I keep forgetting there's supposed to be a b here. It's supposed to be a b right there. So I k1 b e to the minus I k1 times 0 is equal to I k2 c e to the I k2 times 0. So again, all of these e to the I zeros becomes zeros. So this just becomes 1. So you end up with I k1 a minus I k1 b is equal to I k2 c. So, or you have k. All right, I'm going to create a new page here. I'm running out of room. So let's write that equation 2 down. Here, let's write both our equations. So we have equation 1 is a plus b is equal to c. And then equation 2 is I k1 a minus I k1 b is equal to I k2 c. So the i's cancel. We have k1 a minus k1 b is equal to k2c, or k1 times a minus b is equal to c, or k1 over k2 times a minus b is equal to c. All right, so now we have our two equations here for our boundary conditions. So now we just want to represent b and c in terms of a, k1, and k2. So let's go ahead and say, we'll say b. It's going to be a bit of math here, so I'm going to create a new page, and I'm going to write 1 a plus b is equal to c, and 2 k1 over k2 times a minus b is equal to c. So b is equal to c minus a. And since we already have c in terms of a and b, we can say this is equal to k1 over k2 times a minus b minus a. And then we can expand this out, and we now have k2b is equal to k1a minus k1b minus k2a. So doing a little bit of reorganizing, k2b plus k1b is equal to K1A minus K2A. So pull out the B here, K2 plus K1, and that's equal to A times K1 minus K2. So now we're given B is equal to A. Just solve for B. So K1 minus K2 over K1 plus K2. So that's B in terms of just A, K1, and K2. Now for C, we have this equation here. So I'm going to draw a line and say, so C is equal to K1 over K2 times A minus B. And since we just solved for B in terms of A, we can plug this back in here. So we can say is equal to K1 over K2 times A minus A times K1 minus K2 over K1 plus K2. So we can distribute the K1 over K2. So that equals K1 over K2A minus K1 over K2A times K1 minus K2 over K1 plus K2. Now we can pull an A out times K1 over K2 minus K1 over K2 times K1 minus K2 over K1 plus K2. And then we can pull out this again. So we can get finally C is equal to A times K1 over K2 times 1 minus K1 minus K2 over K1 plus K2. All right, so now we have our coefficients B and C in terms of only A, K1, and K2.